What if the Earth itself was trying to tell us a story, not through words, but through an ancient, silent language etched across its surface? From the swirling dunes of the Sahara to the icy scars of ancient glaciers, our planet is covered in unseen glyphs waiting to be deciphered. Prepare to unlock the hidden narratives of deep time written in stone and wind. Earth is a library written in geological code. Every canyon, ripple, and ridge is a character in a narrative spanning billions of years. We pass these formations daily, seeing landscape where we should be reading text. Desert dunes aren't random, they're precise records of atmospheric conditions. Time-lapse reveals their patterns shifting like cursive script, each curve documenting wind direction, velocity, and seasonal variations. Sand grain size and composition tell us about source regions hundreds of miles away. These aren't just pretty formations, they're meteorological archives written in sediment, preserving atmospheric history more accurately than any instrument. Ventifacts, rocks sculpted by wind-blown sand, are fossilized weather reports. Their abraded surfaces point directly into prevailing winds from millennia past. The angle of wear reveals wind strength, the depth indicates duration. By mapping ventifact orientations across regions, scientists reconstruct ancient atmospheric circulation patterns with stunning precision. We can identify when the Sahara was grassland, when monsoon patterns shifted, when climate zones migrated. These wind-carved glyphs provide crucial baseline data for understanding current climate change, proof that Earth's atmospheric systems have written their autobiography onto every exposed surface. The ice tells even grander stories. Glacial striations, parallel grooves carved into bedrock, record the exact direction massive ice sheets traveled. Erratic boulders, transported hundreds of miles from their source, map glacial extent with geological certainty. The depth and spacing of striations reveal ice thickness and movement rate. These aren't vague indicators, they're precise measurements preserved in stone. By reading these icy glyphs, we've reconstructed multiple ice age cycles, understanding that Earth's climate oscillates dramatically over geological time. Current warming trends gain context when read against this deep time narrative. We're living in an interglacial period, but one now being rapidly altered by human activity. Below the surface, Earth's interior writes with even more dramatic force. Fault lines are sentence breaks in tectonic narratives. Seismic signatures, the pattern of past earthquakes preserved in displaced rock layers, document the planet's internal restlessness. Volcanic rock formations reveal eruption timing, magma composition, and the evolution of Earth's molten core. These subterranean glyphs tell us about continental drift, mountain building, and the dynamic processes that continue reshaping our world. Recent advances in seismic tomography let us read these underground texts with unprecedented clarity, revealing that the Earth beneath us is as active and communicative as the atmosphere above. This isn't academic curiosity, it's practical prophecy. By learning to read Earth's geological language, we predict future climate shifts, anticipate seismic activity, and identify resource deposits. The patterns written in ancient dunes inform climate models. Glacial records calibrate ice sheet collapse predictions. Seismic glyphs reveal where future earthquakes will strike. We're not just reading history, we're learning to speak Earth's language fluently enough to understand what it's telling us about tomorrow. Every geological formation is a word in an ongoing conversation, the planet explaining its processes to anyone willing to learn the syntax. The Earth has been writing its autobiography for 4.5 billion years. We're finally learning to read it, and the story it tells is both humbling and urgent. The unseen glyphs were never hidden. We simply didn't know they were text. Now that we do, ignoring them isn't an option.